All right, so this is 10-2, the beta lesson on difference of means. Now, this slide, I'm not really crazy about. We'll get to it in the next slide. The null is the difference of means equals the hypothesized value. That doesn't mean anything to you because it's always going to be 0. We are testing to see if the difference between the two means is 0. This is just theoretical. Meaning after you leave this course, you can test if the two means are something else. But every question we're going to do and every question the assessor on May would be if the difference is 0. Reject or fail to reject the null. And they get to it in this slide, okay? Now, this is the way I used to do it. We're testing to see if the two means are the same. But I kind of figured this out, that this is a superior way to write it. That the difference of the two is 0. And the reason it's superior is it prompts you to look for 0 in the confidence interval. Just take my word. See, I know that some people want to be contrarians and argue. That's the best way to write the null. Now what? Well, I got the conditions. So the conditions are SRS if it's an observation, random assignment of treatments if it's an experiment. 10% condition. We are sampling. This goes for everything. It could be a proportion or a mean. That's why these two are first and second. Because they go across proportions and means. The sample's got to be less than 10% of the population because we're sampling without replacement. And the algorithm expects you to put something back in. So we're not putting people back in. So we can't have our sample be more than 10% of the population. And what? The next one would be approximately normal. So that if there's a proportion, we would say that n times p sub 0 has to be greater than or equal to 10. We don't have proportions. So we need information that the populations are approximately normal, or that our sample size is at least 30. If we don't have either one, we draw a box plot and show that it's symmetric. And that means you metaphysically draw a box plot on your AP answer sheet. Sketch it freehand. So here's we got this data. And it says, has the mean hours that people work in the country changed from 1975? So I need you to understand something. Ready? And it says, we all need to do this because I'm guilty of this too. I'm guilty of saying, all right, let's show you how to put it in the calculator. But we have to start here. State the hypotheses. Check the conditions. We'll have time to put the data in the calculator. So the hypotheses would be, ready? That the use of 2014, the average weekly hours of workers in the country in 2014, take away the average in 1975 was 0. See, because if you look at this table, you can see that the mean's higher. But the question says, has it changed? And change is telling you two-tailed test. It doesn't say test to see if the hours have increased. In theory, maybe they decrease. Like the thoughts were in 1975, with technology, people wouldn't have to work as many hours. It didn't happen in practice. So we're looking at this thing, and you have to say, well, it's not in here, it's on the slide before. Have they changed? Do these data give convincing evidence at the 5% significance level of a difference in the true mean? A difference is telling you two-tailed test. So you would use a not equal symbol in the alternate. Okay? Conditions. SRS, way less than 10% of the population, and the sample size are plenty big enough. Here's the sample size for both rolling and 30. Okay? So what did we do? We wrote the null and alternate, we checked the conditions. Now you're going to go to your calculator. Now watch what happens. Go to, I can do this for you if you want, but I think it's, you can do it. Stat test 4. And on stat test 4, do you notice what the top is saying? The top option is saying data or stats. Yes? Go to data. What are the prompts asking for? Your lists. Where is this data? We don't have the data. We have the summary statistics. Go right-hand arrow. And what are we going to do? Well, the way this is written, now it's not going to matter, but just pay attention. The way it's written, we would put 2014 first, because the null is 2014, take away 1975. If we mixed it up, it doesn't matter. It would just reflect your answer over the y-axis. So it's not a deal breaker if you put it backwards. But why would you intentionally put it backwards? Okay? So what have you got? The mean, the step, and the sample size for each of them. Yeah, I'm going to keep going through the slides while you're doing that. Does anybody need that data anymore? Yes, it has to be the slowest typer. Go. Right there. Next. What is the test statistic? It's your t-score. It's how far your difference is from 0. And I've got the standard deviation of the first one, which is 2014. The second, which was 1975. They were the standard deviations. I have to square them to get the variances. Then you divide by the square root of the sample size. But that is the square root of the sample size. You put the whole thing under a root sign, and you can distribute an exponent over division. So this really is the same thing as saying, ready? You can't distribute it over this addition, but over the division. So now we're here. There's the table again. So why do we have some evidence? Well, we have some evidence because there's a difference between the two. It's not 0. It's 2.94 hours more. You just subtract it. But is that statistically significant? So you go here. Ready? You go to your calculator and push calculate to get the p-value. You got the data in there. Look at this t-score. It's almost 5. You understand what that means? You have this picture, and here's 0. Your t-score is way over there. You're in the tail. Reject it all. You found something. There is evidence of a difference in the mean hours of workers between 75 and 2014. What's the p-value of your calculator? What's the p-value? It's just perspective. It's scientific notation, it's so small. Yes? It's essentially zero. The likelihood that we got this difference by chance alone, if there were no difference, is essentially zero. There is evidence of a difference in the hours that people are working. They're saying 1/10 of 1%. Now, this is what you have to pay attention to. Second quick. Stat test 0. What do you see when you go stat test 0? Nobody sees anything? The calculator brought the data forward. The calculator did it for you. It took your data from stat test 4 to stat test 0 because they go together. Stat test 4 is a test. Stat test 0 is a confidence interval. They're connected. So you don't have to retype the data. Yes? Now, think about this. We were here. Way off the curve. Okay? Only 1/10 of 1% of the curve is shaded in. What do you expect to happen when you push calculate for stat test 0? Try and figure it out before you push it. Somebody at home, check me. What's going to happen before you type it on stat test 0? Go ahead, check it out, push enter, and tell me what you say. What about the interval? What does the interval have to do with the null hypothesis? Read the interval to me, please. The interval is 1.75 to 4.12, yes? Yes? What's not in the interval? Zero. See, the null is that zero's in the interval. Because if zero's in there, there's no difference. If zero's somewhere in the interval. But if zero's not in there, if the interval goes positive to positive or negative to negative, that's confirming that you would reject the null on the test. Zero. That's why we write the null this way. Because you're looking for zero in the interval. And if it's in there, you would F2R. You would fail to reject the null because zero's in there. If zero's not in there, that corresponds to rejecting the null. It's a 95% confidence interval. We're 95% confident that the true difference in working hours is between 1 3/4 and 4 1/8 hours more. That's what we're 95% confident about. Okay, it should be a 95% confidence interval. You have to go back to the test because they told us in the question the alpha level is 5%. Now, this, we're not doing this, but look at this. This is saying, does putting calcium, eating calcium, consuming calcium, help your blood pressure go down? So this is an experiment. Except what do you have? We don't have the summary statistics. We have list 1 is the treatment group, and list 2 is getting the placebo, or the control group. So we would go to stat test 4 and stat test 0, but we would use lists there. We're not putting this in the calculator because we'll do it. But that just goes with what's going on. But in order, we got to do the conditions first, yes? So we have to have random assignment of treatment. The sample size is not going to be anywhere near 10% of the population. But look at the sample size. 2, 4, 6, 8, 10, and 11. They're both less than 30. So we either have to know that the populations are approximately normal, or we have to draw a box plot. Now, on these PowerPoints, they're drawing dot plots. Ready? You can do that in May. It would be silly. Because you're putting the data in your list anyway. So the calculator will draw a box plot for you. And that means you would draw a box plot for this. That the AP reader is looking for your box plot. So what happens in this problem? You get a p-value of 1.6. Uh-oh, over here in the curve, we're at 1.6. That's what's shaded. Not way over there. Like the data about the, what was it about? Oh, the working hours. So now what? The p-value is 6%. See, in that picture on the board, that's supposed to represent 6% of the area of the curve being shaded in. That's bigger than the alpha level. Listening? That means you're going to fail to reject the null. Now, we're not doing this, but I'm telling you this. I'm telling you that if you put these numbers in list 1, we're going to do a problem. That's why I don't need to do it right now. You put these numbers in list 2, 1 and 2, and you did stat test 0, what would happen on your confidence interval? 95%. See this? The p-value is bigger than the alpha level. F2R. If we F2R, what would happen on the corresponding confidence interval? That's fine. You don't get it? Type it in. Let's go. Get it both ways. I'll call it out. Go to list 1. Ready? 7, enter. -4, enter. 18, enter. 17, enter. -3. -5. 1, 10, 11, -2. That's list 1. List 2. -1, enter. 12, enter. -1, enter. -3, enter. 3, enter. -5, enter. 5, enter. 2, enter. -11, enter. -1, enter. -3, enter. You should have 10 entries in list 1 and 11 entries in list 2. Yes? Second quick. Stat test 0. Do a 95% confidence interval and tell me what happens. Zero's in there. 0 has to be in there. Why? Because the null is there's no difference. The null is the difference equals 0. And we already failed to reject the null. Because if the p-value is higher than the alpha level, we're in the body. And we F2R. And if we F2R, 0 has to be in the confidence interval. Because we're failing to reject that the difference it means is 0. So we're failing to reject that it's 0, it's because 0 is in there. And 0 being in there is because it complements, not because, it complements that 6% higher than 5%. Here's what we're good at. Honestly, it's not any different than the other one. People are really good at putting their head down and doing what I told you to do, which is grunt work. Putting that data in a calculator and pushing buttons. You need to anticipate what you're going to see. Even if you don't have to do it out loud. I expect to see 0. I don't expect to see 0. And see if that's what happens. And then go back and say, well, why did I say that? And why was I correct? Why was I wrong? Ready? You looking up here? Always choose no for pooling. Pooling is not part of the AP Calculus curriculum. Never pick pooling. And it's kind of clear, I think, because no is the default against the left. Now, what's that? That is their data from the hours of working. And there's the t-value, and there's the p-value, which is essentially 0. Now, this is different. Degrees of freedom. Remember when we told you degrees of freedom is 1 less than the sample size? Yeah, it's a floating definition. Degrees of freedom is a continuous distribution, meaning you're pushing down on the standard normal curve. You don't push down on it and then stop, and push down and stop, and push down and stop. Like a second hand that stops, it pauses as each number. You're pushing down on it consistently, so that's why you get a decimal answer. All you do is write it down, what the degrees of freedom are. That's beyond the scope of the course. All right, and then this is the data for the hours, or for the calcium, and then that's it. All right, well, other than this, which is where it started, okay? So we're going to go to the PDF. Somebody chatted me? No, 0, thank you. So here's what's going to happen. There is nothing to tell you. It's just the null. Is the difference is 0, which means they're the same. Let's communicate the same thing. We're doing one data set, one problem. Well, it's 2 questions, but it's one data set. 59 and 61. So go to the question. What are you doing? You're writing the null and alternate. You're writing the conditions. And then you're going to do the calculator. Problem 59 and 61 in 10-2. So we're going to pause the video. All right, so 59. 59 is the test, and 69 is the confidence interval for the same data. Here's my null. The difference of the words spoken by women, subtract the difference of the words spoken by men is 0. And the alternate is it's not 0. They're just saying, is there a difference between the two? They're not saying if girls talk more or if boys talk more. They're not channeling you to put inequality. They're saying, is there a difference? So the sample sizes were 56. Which are both bigger than 30, and they're way less than 10% of the students of the school, boys and girls. We have an SRS. So we put the data in stack test 4. Careful, you got to pick not equal to for your alternate. Okay, don't pull it. And I drew it instead of calculate. And look at this picture. Look how much is shaded in. That's telling you F2R. You reject the null when you're way out in the tail. The probability of getting the t-score we got, which is negative 0.2484, that's where it is, negative 2484, or more extreme to the left. Two-tailed test. We flick that over the y-axis. That's why all that's shaded in. The likelihood of getting that, or more extreme by chance alone, had the null been true, is 80%. F2R. So therefore, when we go to the confidence interval, what's going to be there? Zero has to be in there because we failed to reject the null. And the null is the difference is zero. So when we go to stat test 0, we don't have to reload this data. And our interval is here, negative 3,500 to 2,700. It includes 0. See, we're looking. Did it go from negative to positive? We're 95% constant parameters between that. Zero's in there, F2R. All you're looking for every time when you do these confidence intervals and the difference of two proportions, the difference of two means, you're looking for 0 in here. Because 0 would be the null. And if it's in there, fail to reject the null. And if the interval goes from negative to negative, or positive to positive, then you reject the null. So that's that for 10 to beta.